Hello, friend. Today we will be talking about polynomial modeling. So the first thing we do is read the question. A man is creating a pool at the backside of his house using 600 feet of fencing for 3 sides, and his house as the 4th side. So the second thing we do is draw a picture. Whenever you're doing a polynomial model, you want to draw out the picture so you can visualize the sides and the dimensions. So this is the house and this is the pool. And since we know that there's 600 feet of fencing, and we also know that there is 3 sides. Yes, we know there's 3 sides. We take out 2 widths and a length. So the second thing we do is we add them together to equal the 600 feet of fencing. So we just add these 2 widths, plus the length. So length plus 2 widths equals 600 feet. And 1 length and 2 widths will equal the area of 600 feet. And we would subtract the length on both sides so it can we would subtract the 2 widths on this side so that the L can remain by itself. 600 feet minus 2W. This will come into play a little bit later because area equals length times width, and this is your length. So area equals length times the width. And because your length is 600 feet minus 2W, so A equals 600 times 600 minus 2W times W. This is your area. And we multiply and FOIL the W times negative 2W and the W times 600. So it would become A equals 600 W minus 2W squared. This is your function.
Hello, for part 2, or B, we are finding the domain of the function. So we already have the function in terms of W from part A. So we are going to find where part A is greater than 0. So I'm going to write that over here for us. 600W minus 2W squared is greater than 0. So for this, I like to put this in a number line, so it's a bit more visual. So do a little number line over here. And the points on the number line that we need to find are the zeros of the equation. So first we got to find the zeros of the equation. So we're going to minus 2 squared. We're going to take out a W, or 2W, as our greatest common factor from this. So we can take 2W of 300 minus W. We have our 2 terms right here. Let's set them both equal to 0. Divide by 2 on both sides. We'll have W is equal to 0. So first 0 over here. Second term, I'll have 300 minus W is equal to 0. Add 300. Negative W is equal to negative 300. We divide by -1 on both sides. And that'll give us W equals 300. There are two zeros right here at 0 and 300. Give myself a little more room here. So we have our zeros. Now I like to do testing points before, between, and after our zeros to see if it is above or below our number line. So we'll start with just -1. We'll let 600 times -1 minus 2 times -1 squared. Just take a look at this. It's going to be -600 times -1 minus -1 squared is +1 times 2, still 2. So -2. That'll give us about -602. So we have a negative before 0. We can keep it simple, just do 1 right between them. 600 times 1 minus 2 times 1 squared. Take a look at this. We just have 600 minus 1 squared is 1 times 2 minus 2. That'll give us 598. Positive number. So we got positive in between the two. The last checkpoint is after 300. So just do 301. Pretty simple. We'll do 600 times 301 minus 2 times 301 squared. It's kind of bigger numbers. 600 times 301 is, can you get a calculator?
-602.
It's
600 times 301.
Yep.
Minus 2 times.
301 squared.
Oh yeah, that was definitely wrong. 600 times 301 minus 2 times 301 squared. -602.
All right, we're gonna total gonna be -602. I have a negative number here. So you can see either algebraically or on a graph, what we're gonna have is on that curve, we're gonna start negative over here. And we hit this 0, we're gonna go positive. We're gonna come back, hit this next 0, and then we're gonna start going negative. So we have a little rough sketch here. What we can take from this, where our W is gonna be greater than 0, is from 0 up to 300. But at 0 and 300 is equal to 0, so they are not included. So we're going to do parentheses here from 0 to 300, and that's going to be our answer.
Okay, so for part C and D, we're just going to put them together because they kind of coexist. So for C, we're going to determine the dimensions of the pool that gives us a maximum area. So to do this, we're going to take our equation from part A, which is A of W equals 600 W minus 2W squared. And to find our max area, when you look at it on a graph, we have our vertex. So we're trying to find the x value of our vertex, and that equation is -b over 2 times A. So we're going to take our -b, which would be 600, so -600 over 2 times A, which is -2, which equals 150 feet. So our W equals 150. Now to find our length, we're going to take an equation previously, which is just L equals 600 minus 2 W. And so we're gonna take our W, which we know is 150, and we're just gonna put it here. So 600 minus 2 times 150, which equals 300 feet, or our L equals I'm just gonna put them over here. Okay, now to find the maximum area of our pool, we're gonna take, or so we know that our length, or I'm sorry, our area equals length times width, and we know our length is 300 and our width is 150, so we can just multiply those together, so we get 300 times 150, which equals 45,000 feet squared. So our area, our maximum area equals